In this tutorial, we'll discuss timelines, what they are, and the keywords associated with them. First, let's discuss what timelines are. Think of a timeline as an event generator for a specific activity. This activity can have one or more events, or parts to it. If this activity has more than one unique event, and something different must be done at each event, they can be identified by the timeline sequence number. Timelines can be used for many things, including feedback and time-of-day events. A timeline is represented by the illustration in this figure. The Netlink's timeline functions provide a mechanism for triggering and managing events, and these events are based upon a sequence of times. One of these functions is timeline create. When the timeline create function is executed, the timeline starts at 0 and begins counting. A value is returned from the call which represents its success or failure. The possible values are shown here. A value of 0 means the timeline was created successfully. To create a timeline, the timeline create function is used. Each timeline is identified by an ID number. That number is typically stored in a constant that describes the timeline's use. Let's assume our timeline ID is represented by the constant TL1. This ID must be unique and defined as a constant either in the defined constant section or in the defined variable section. The sequence of times required is passed into the timeline create function as an array of long values, with each value representing a time period in milliseconds that is either absolute from the start time of the timeline or relative to the previous time in the array. Take a look at the time array defined here. We'll use this to create a timeline that will generate an event every second for 5 seconds and then end. This is an example of one way to create a timeline which generates an event every second for 5 seconds. TL1 is the ID of our timeline. ATMTL is the array of times. The number 5 is the number of time elements in the time array. Timeline absolute means we wish to have each time considered to be absolute from the start of the timeline. And timeline once means we want this timeline to run to completion only once and not repeat. When the timeline's timer value equals a value in the times array, a timeline event is triggered. This is where the code goes that occurs for a particular timeline's trigger. Within the timeline event, a timeline structure is available to get information about the specific timeline event. Notice that timeline.sequence updates its value within the timeline event to represent the index number of the time array for the time currently causing the event after 1 second, 2 seconds, 3 seconds, 4 seconds, and finally 5 seconds. The Netlink's language supports the following timeline keywords. Timeline active. This function is used to determine if a timeline has been created. If the timeline is not active, this function returns 0. Timeline create creates an initial timeline and specifies the attributes of the timeline. Timeline event. These events are generated when a timeline's internal timer is equal to one of the specified times in the times array. Timeline get. This function returns the value of the specified timeline's timer. The timer indicates the number of milliseconds that have passed since the timeline started. If the timeline is paused, the timer is also paused and subsequent calls to timeline get will return the same value. Timeline kill. This function is used to terminate a timeline. Any further references to the specified timeline ID are invalid. It's always best to see if a timeline is currently active before attempting to kill it. Timeline pause. This function is used to suspend the execution of a timeline. It may be restarted from where it left off with the timeline restart function. Timeline reload. This function is used to change the array times of a timeline. The new array of times takes effect immediately, even if the timeline is currently executing. If the timeline is executing when this function is called, the timeline continues to execute, and the next matching time from the new array triggers an event. Timeline restart. This function is used to continue execution of a timeline that was suspended with timeline pause. Timeline set. This function is used to modify the current timer value of a timeline. The timeline's timer is immediately set to the new value regardless of whether the timeline is executing or not. The old way of programming time sequences was to cascade or nest waits. Using nested waits hard-coded the time sequence, so the only way to modify the timing was to modify the Netlinks program, recompile, and re-download. Timelines make adding, deleting, and editing the sequence much simpler for the programmer. Timeline functions and debugging allow the timings to be modified without the modify, compile, download cycle because the array of times may be modified via Netlinks debugging. Once the timings have been tweaked, the changes can be incorporated in the Netlinks program by entering the adjusted times into the time array. Because timelines have a specific repeat time, they don't have the same issues as using the defined program section does, especially when using an NX processor. With timelines, feedback will repeat at regular intervals, regardless of whatever else is happening. It's important to note that this is not necessarily the best place for all feedback. If a particular feedback process takes a relatively longer time to perform, you may want to put that in a separate timeline with a larger repeat time. Also, for level feedback, you may want to provide the feedback for a level event as it occurs. The value you choose for your repeated time should not be too small, as this would take time away from processing other activities and events, and not so large that feedback appears sluggish. Experience tells us that using a time between 200 and 300 milliseconds is acceptable. The most important point to take away from here is to remember not to overload your feedback processing to the point where it takes longer to finish the feedback processing than the delay between feedback loops. Now that we have an idea of what timelines are, in the next tutorial, we'll be demonstrating how to build a timeline in Netlinks Studio from start to finish.